Now the next example is from the year 2003 CE. Now a uniform wood of weight 50 Newton is supported by two spring balances P and Q and remains at rest as shown below. Assume the weight of the wood X through its midpoint. Find the readings of PQ. Now let's look at the free body diagram. So we call the force provided by the spring balance, we call it R. Okay, we call it R. Just call it P and Q. Just call it P and Q because we're doing MCs. All right, P and Q, and then the length is 0.5 meter. So there's one force missing in the diagram, that is the weight of the rod, okay, which should be, what is it, 50 Newton. The weight of the rod should be 50 Newtons. So which should act at the center. Now so the whole length is 1 meter, isn't it? The whole length is 1 meter. So the weight acts at a point which is equal distance from the two ends. So from the weight to this end, total length is 0.5 meters. So this part, this length is also 0.3 meters, right? And similarly, the weight is 0.5 meter from the right end. So the distance of 50 Newton from Q, from the force Q, is 0.2 meters. So this is the free body diagram. So this is the free body diagram. So we can take moment about P. About P. We take moment of P. The sum of clockwise moments equals to the sum of anti-clockwise moment, right? So we take moment of P. Now there are only two forces which can provide moment about P. So the clockwise moment is provided by the 50 Newton. So 50 times 0.3 equal to the anti-clockwise, which is Q, and the moment arm is 0.5. So therefore Q equals to 3 newtons, is it? Or 30 Newton? 30 Newton. Okay. So the net force should be equal to 0. So P plus Q, what is it? So P plus Q equals to 50. So Q equal to P plus Q equal to 50. So P equal to 20, isn't it? 20 newtons. So P20, Q30, that gives us the answer should be B. Okay, the answer should be B. Now let's take a break before the next